we're going to talk about, up to now you have done Lewis structures and molecular models on things that conform to the octet rule. And of course hydrogen we know gets what they call a duet. It's got two. So you've got your lovely little ammonia. And you've all drawn this a bunch of times. And you know that unshared pair up here is going to force all those hydrogens down. They're going to be equidistances from one another. If we were really going to draw this three-dimensionally, we would find a way to do what these would be equidistance, and then somehow superimposed up on top of these would be your unshared pairs. We can't really do it very well. That's why we make models. And these are easy. We do the Gooch math. Well, what happens in a case of something like, and this is actually one that's on your lab, but you'll do it for yourself. This is called sulfur hexafluoride. Hexamine 6. It's one sulfur bound to 6 fluorine. So let's try the Gooch math, shall we? So we'll do the valence first. And sulfur comes in with 6. Fluorine comes in with 7 times 6. We have 6. We have, what's that, 42? So we have 42 valence electrons. If everybody was satisfied with octet, everybody here wants 8, so we would have 8 times 7, 56. So 56 minus 48, we have what? 8 shared, which means we have 4 bonds. Anybody see a problem right off? I see a big problem.
You have 6?
You have 6 things tied to sulfur. You can't tie 6 things together with 4 bonds. It can't be done. So, what happens is something that we call expanded valence. So what do you know about fluorine? Fluorine has got one distinction going. It is the most electronegative element there is. It is the biggest electron hog that exists. Okay? If there are electrons, it's pulling them very close to it. So what happens with sulfur, and I'm gonna sort of drop back to the old model that you used in physical science, where we look at this sort of Rutherford Bohr model. So let's look at our sulfur. So if we go back to this sort of, thought with the old Bohr model, and we look at it this way. Normally when sulfur's bonding, it's going to form what? 2 bonds, because it's missing 2 electrons in that uppermost energy level. So it'll share 2 electrons in that uppermost level, and it'll be satisfied. What happens with fluorine is these electrons that are down here, that are not valence electrons, actually get sort of pulled out. And they actually participate in bonding. It's called expanded valence. It happens because, number one, sulfur's got the additional electrons. It's a big enough atom that it's got those extra levels. And 2, fluorine is so darn attractive to electrons, they will run through walls to get to it. So what we have is this expanded valence bonding. Now, you can't make the math work on this. You're kind of flying blind here. And you don't have to, I find it helpful to understand conceptually what's going on, that in fact you've got electrons from lower energy levels that are sort of being pulled up to the surface because fluorine's got such a powerful reach. But you don't have to understand that conceptually. I'm not going to ask you about it on the test. I find the whole concept easier to understand if I know that. So I'm telling you that because I think it makes more sense. what that does, so we can totally get rid of the gooch math because it's useless. It serves no purpose for us here. Because when we're dealing with something with expanded valence, the gooch math just doesn't work. Sometimes your first clue that you're dealing with something with expanded valence is that you do the gooch math and you're like, oh, I have 4 bonds. Wait, I have 7 things. That doesn't work. That may be your first clue that you're dealing with something where there's going to be expanded valence. So in the case of something with expanded valence, how do you approach this from a Lewis structure perspective? Well, you just start drawing the darn thing. You know that the least electronegative thing is going where? In the middle. So we're putting sulfur there, and we're basically just going to hook everything together with single bonds. Now, how many electrons does sulfur feel like it's surrounded by? 2, 4, 6, 8, 10, 12. It's blown octet. It's got 4 more electrons than it could possibly have. It's okay because honestly the fluorine is pulling so much of the electron cloud towards it that it's almost like sulfur doesn't feel crowded. Now, unshared pairs, fluorine started off with 7 electrons. It's still got all those unshared pairs. That's it. If you are going on in chemistry, there are some things with looking at things like formal charge that give you some slightly better analytical tools to assess whether or not what you have is a good structure. We don't go that far here, so I won't say it's sort of by guess and by God, but it's sort of by trial and error. Yeah. Put it together. Things, sulfur came in with, 2 unshared pairs. Those have given up and gone to sharing. Plus some additional stuff has come up from lower levels to share. And, so the things that don't work for octet, obviously, in your case, the hint is that, hey, they're the ones that don't appear on the gooch math sheet. So the Lewis structures are a little bit more trial and error with these. I did this differently this year. I used to teach all the Lewis structures together, so the normal conforming ones and the non-conforming ones. And I thought this year I'd try something new, which is letting you get really good at the conforming ones and then throw you the monkey wrench. I think it may work better. I don't know. Because you got a lot of confidence, I think, at this point on the conforming Lewis structures. You're all pretty good at those. The other exceptions to gooch math, the things that are octet exceptions, and these are sometimes called octet deficient. So if you remember, we said that there are a couple things that are satisfied with less, you got it? Okay. Less than 8 electrons, and so you'll see some on there. When you get down to things like beryllium and boron, beryllium is satisfied with less than 8. I'm not going to give you a whole lot more information than that. And boron is satisfied with less than 8. If you go all the way back to the octet notes that we did, that's in there. So I'm going to let you get started on these. And the model making kits have central atoms that are set up for octet violators. So for both expanded valence and valence deficient, octet deficient. So that's really all we had to do. Yes?
For the doctor, maybe I'll just area.
Yeah, absolutely. That's it. Go.